This is 7.3, the unit circle. So here, the unit circle is just basically a center, or has a center of 0, 0, and a radius of 1. So if you think about the circle, it kind of looks like this. Okay, so here's a circle. It has a radius of 1. So that means all around is going to be a radius of 1. So the distance here is just going to be 1 meter, inch, I don't know, whatever. Okay. So that's all it is. Here's the equation of a circle. X squared plus y squared equals 1. So 1 here represents just the radius. So that's just basically all it is. I give you here a couple of examples. So whenever the radius is 1, we can treat, and you have some angle t, then actually your x-coordinate is going to be your cosine, and your y-coordinate is going to be your sine. Okay, so that's really important to kind of take a note of. Okay, so the way that I like to remember it is that x comes before y, just like c comes before s. So you can kind of see that that's how these two guys are related. So x goes with cosine and the y goes with sine. It only works when the radius is 1. Okay, and you can kind of think about it this way. So if you have an angle t or theta or whatever you want, and you know that this is x and this is y, and then the radius here is 1. Well, in this case, if you look at the cosine, so the cosine of t is going to be the adjacent over the hypotenuse, which is just x over 1, which is just x. Same thing with the sine of t. That's just going to be the opposite over the hypotenuse. That's y over 1, which is y. So you can kind of see why it is. If the radius was something else, then it would be a little bit different. And we'll talk briefly about when the radius is not 1. But we're going to extensively talk about when the radius is 1. So let's start off with the sine of 90 and the cosine of 90 degrees. Okay, so let's try to figure this out. We already know how to do this in the calculator, but let's just pretend that we don't know how to do it in the calculator. So remember that if I look at the quadrantal angles, here's 0 degrees, here's 90 degrees. So if I was looking at a circle, and you were looking at this, well, if I think about this point that is on the 90-degree angle, that's just the point 0, 1. So that means that the cosine of 90 degrees is going to be the x-coordinate. In this case, the x-coordinate is the first number, which is going to be 0. And the y-coordinate is going to be the sine. So the sine of 90 degrees is going to be the 1. Okay. Oops, that's wrong. It's going to be the 1. It won't erase. Okay, so that's what the answers are. Okay, just by looking at the angles themselves. So it's good to know where these numbers are coming from, because anyone can just put it in the calculator, but you really need to know, oh, where exactly are these coming from? And they're coming from the unit circle. Okay, so here's another problem. So find sine of t and cosine of t given the following diagram. So in this case, notice that they didn't give us an angle. They just gave us a random value of t. I don't know what t is. T can be whatever. It's clearly between 90 degrees and 180 degrees. So sine of t is just going to be the y value. So here, if we see the x and the y value is going to be square root of 2 over 2. The cosine of t is going to be equal to the x value. That's going to be negative square root of 2 over 2. Okay? And that's it. Okay? All right, so now let's go down. Something to kind of note is that the sine and the cosine will change signs depending on what quadrant you are. So depending if you're in quadrant 1, quadrant 2, quadrant 3, whatever, you're going to have different signs. So here, if you're in quadrant 1, everyone is positive. Okay, don't matter what it is, sine, cosine, tangent, cotangent, whatever it is, all of them are positive. If you're in quadrant 2, only sine is positive, as you saw over here. We saw here in quadrant 2, you can see that the sine was something that was positive. The cosine was negative, okay? So that means that in quadrant 2, sine is positive, everyone else is negative. Quadrant 3, tangent is the only one that's positive, okay? Everyone else is negative. And in quadrant 4, cosine is the only one that's positive. Everyone else is negative. Okay? That's not including the reciprocal functions. We'll talk about the other reciprocal functions like cosecant, secant, and cotangent later. Okay? A good way to kind of remember it is all students take calculus. Okay? So ASTC, all students take calculus. That tells you where all of these values are positive. Okay? So here is an example. So use the given sign of the sine and cosine functions to find the quadrant in which the terminal point determined by t lies. Okay, so here it tells you sine of t is less than 0 and cosine of t is less than 0. So if you have a number that's less than 0, what does that mean? Well, that means that they're negative, right? So that means this guy is negative and this guy is negative. Okay, so we got to think about in here, where is the sine and the cosine both negative? Here, all of them are positive, so it's not this guy. It's not this guy, because sine is positive. It must be this guy, because sine is positive here. So the only one that's positive is tangent in quadrant 3. Sine and cosine are negative. So, this guy is going to be quadrant 3. Okay? So the second one says, the sine of t is greater than 0, that means it's positive, and the cosine of t is negative. So where are both this guy positive and the other one negative? Well, sine is positive only in quadrant 2 and in quadrant 1, but we know that cosine has to be negative, so it can't be quadrant 1. It has to be quadrant 2. Okay, and that's basically it. Okay, so really make sure that you really understand where all the signs are at. Okay, all right, so here we go to the Pythagorean identity. So from the unit circle, we know that x squared plus y squared equals 1. So for any angle theta, we can say that the cosine squared theta plus sine squared theta equals 1. You need to know this. Okay, even if you decide not to memorize it in future classes, this is going to be really, really important. Cosine squared plus sine squared equals 1. Now you're wondering, where did this formula come from? Well, what is x equal to? X is just your cosine. What is y? Y is just your sine. So that we just plug them in. Now usually we don't write sine of theta squared. Okay, this thing is the same thing as saying sine squared theta. Okay, this is not the same as sine theta squared. That's not correct. What you're doing is you're squaring the whole thing. You're not just squaring the theta. Okay, you're squaring the entire thing. Okay, so if we are given either sine or cosine, we can find the other one by the above equation. Now you have to be very careful because when you solve a square function, you have to apply a square root. So when you apply a square root, you have to add plus or minus, because as we just saw, the sine and the cosine can be positive or negative depending on where we're at. Okay, so let's start off with this problem. So if sine of t is equal to 3 over 7 and t is in the second quadrant, find cosine of t. Okay, well, we know that cosine squared, and now since we're looking at t, we're just going to write t. Cosine squared t plus sine squared t equals 1. We know what sine of t is. Sine of t is 3 over 7. Okay, so we're going to plug in 3 over 7 into the sine. So we have cosine squared t. The whole sine is going to be 3 over 7. This is squared equals 1. Okay, so now we're going to have cosine squared t is equal to, plus, I want to erase, plus 9 over 49 is equal to 1. Okay, so now let's solve for cosine. So minus 9 over 49 minus 9 over 49. So this is going to give me cosine squared t. So we're going to do 1 minus 9 over 49. That's going to give me 40 over 49. Okay, now we need to get rid of the square. So in order to get rid of the square, we're going to square root both sides. But when we apply a square root, we're going to put in plus or minus. So we're going to have the cosine of t. So now the squared went away. And now plus or minus. Now let's figure out what the square root of 40 over 49 is. Okay, so when I do that, I'm going to get 2 square root of 10 over 7. Okay, now we have to think about it, positive or negative. Okay, now we have to think about which one is it going to be, because it can't be both of them. So it tells us that sine of t, or t, is in the second quadrant. So in the second quadrant, what is cosine? So if we look over here in the second quadrant, sine is the only one that's positive. So cosine must be negative. So that means you're going to have cosine of t is going to be equal to negative 2 square root of 10 over 7. So that's going to be my answer. Okay. Now we're going to go to this one. Okay, cosine beta. Okay, so now in this case, we have beta is in the interval of pi less than or equal to beta less than or equal to 3 pi over 2. So we got to think about what this means. Okay, now everything is in radians. Now remember, what is pi equal to? Pi equals 180 degrees. So this actually is a really good learning experience to see about the radians. Because before we saw that we had 0, 90, 180, 270, and then 360. The ones that we really haven't talked about is the radians, but here's the radians. The radians is 0, pi over 2, pi, 3 pi over 2, 2 pi. So these correspond with the degrees. So basically pi over 2 corresponds with 90 degrees. Pi radians correspond with 180, which makes sense. 270 degrees corresponds with 3 pi over 2. 360 degrees corresponds with 2 pi. Okay? So just remember these two. Okay? So basically, if beta is between pi and 3 pi over 2, here is pi, here is 3 pi over 2, that means that we are in quadrant 3. Okay. All right. So now we know what cosine is. Cosine of beta equals negative square root of negative 3/4. So we're gonna first start off with cosine squared beta plus sine squared beta is equal to 1. So let's start off by plugging in negative 3/4. So we're gonna have negative 3/4 here, and I'm gonna square it, plus sine squared beta, we don't know what that is because that's what we're looking for, equals 1. This is going to give me 9 over 16 plus sine squared beta is equal to 1. We're going to subtract by 9 over 16. So we're going to end up with sine squared beta is equal to, so let's put that in our calculator, 9 over 16. So that's going to give me 7 over 16. And now we're going to take the square root to both sides. But when I apply a square root, remember that you also have to add plus or minus. So we have sine of beta is equal to plus or minus square root of 7 over square root of 16 is just a 4. Now in this case, in quadrant 3, remember that tangent is the only one that's positive. So here, the sign has to be negative. Sine of beta equals negative square root of 7 over 4. Okay, and that is my answer. Okay, all right. So not a lot of too heavy stuff, but there's a lot more algebra now. Okay,